200,000 years ago, somewhere in East Africa, a human being is standing in the grass. Not a king, not a warrior, not the hero of any story you've ever heard. Just a person, scanning the horizon, trying to figure out two things: where the next meal is coming from, and whether something with bigger teeth is currently hunting them. Now picture something strange. If that person, standing there 200,000 years ago, could see a photograph of every human alive on Earth today, one thing would jump out immediately. They almost certainly weren't white. They almost certainly weren't East Asian. And they were definitely not a redhead who burns after 20 minutes at the beach. Every human being alive right now, all 8 billion of us, every color, every shade, descends from people who looked like that one person on the savannah. So here's the question this video is going to answer. If we all started the same color, where did every other color come from? By the end of this video, you're going to understand exactly why skin color exists at all, why it changed as humans spread across the planet, why Europeans and East Asians ended up pale through two completely different genetic paths, and why the three-box idea of black, white, Asian doesn't actually match what the science says. And by the end, you'll understand something most people never stop to consider. The categories we argue about today are some of the newest things about being human. Let's start at the very beginning. For most of the time Homo sapiens has existed, there was no white, no black, no Asian. There was just Africa, and Africa sits close to the equator, which means it gets hit with an enormous amount of ultraviolet radiation. Beautiful for a vacation, brutal for unprotected DNA, generation after generation. That's where melanin comes in. Melanin is the pigment responsible for darker skin, and biologically, it behaves like built-in sunscreen, absorbing UV rays before they can damage skin cells or break down a critical vitamin in the bloodstream called folate. In equatorial Africa, having lots of melanin wasn't a cosmetic detail. It was a survival advantage. And evolution doesn't care what looks good. It only tracks one number. Did you live long enough to pass your genes on? For hundreds of thousands of years, the answer favored dark skin. It wasn't a preference, it was just what worked. Then people started walking. Somewhere around 60 to 80,000 years ago, groups of humans began leaving Africa. No maps, no compasses, just movement. Into the Middle East, up into Europe, east across Asia, eventually out to Australia, Siberia, and, almost unbelievably, across into the Americas. And as people moved farther from the equator, something changed beneath their feet without them ever noticing. The sunlight itself got weaker. Less intense UV radiation sounds like a win. Less DNA damage, less risk. Except there's a catch. The same sunlight that damages skin is also what triggers the body to produce vitamin D, which is essential for strong bones and a functioning immune system. So the trait that had been a life-saving advantage near the equator became a liability farther north. Dark skin was still blocking UV rays extremely efficiently. The problem was, in these new regions, there wasn't much UV left to block. People were now at risk of not getting enough sunlight, and when that kind of pressure sits on a population for tens of thousands of years, evolution starts nudging things in a new direction. Here's the part that surprises almost everyone. The first humans to walk into Europe were still dark-skinned. Pale skin didn't appear the moment people crossed the continent's borders. It took an enormous amount of time to spread. Ancient DNA research has completely rewritten what scientists used to assume. Some hunter-gatherers living in Europe thousands of years ago had dark skin combined with blue eyes, a combination that doesn't exist in the categories we use today. The pale skin now associated with Europe became widespread much later, as farming spread, as diets shifted, as populations mixed, and as certain genetic mutations spread through the gene pool because they offered a small vitamin D advantage in a low sunlight environment. Not because it was better, not because it was superior, simply because under those specific conditions it worked. That's the entire story of evolution in one sentence. No master plan, only adaptation. Now here's where it gets genuinely strange. East Asian populations also evolved lighter skin compared to their African ancestors, but many of the specific genes responsible are different from the ones that lightened European skin. Think of it like two students solving the same math problem and arriving at the same answer using completely different methods. Different populations, facing a similar environmental pressure, independently landed on their own genetic solutions. Same destination, different road entirely. That's not a coincidence, it's a pattern evolution repeats constantly. Nature doesn't follow one blueprint, it runs the experiment over and over, in parallel, all across the globe. This is where most casual explanations completely break down. People tend to picture skin color as three neat boxes: black, white, Asian. Clean, simple, easy to remember. Also just wrong. Human pigmentation is a spectrum, not three shades, but hundreds, shaped by thousands of years of local sun exposure, geography, and migration. North Africans differ from West Africans. Middle Eastern populations differ from Europeans. South Asians differ from East Asians. Indigenous Australians followed their own separate evolutionary path entirely. There was never a moment where humanity split into a handful of categories. It diversified continuously, messily, exactly the way evolution tends to do everything else. And here's the part that ties everything back together. Trace any family tree back far enough, doesn't matter whose, and every single branch eventually merges into the same trunk. A population living in Africa roughly 200,000 years ago. The visible differences we notice today are actually one of the newest things about our species. Compared to how long Homo sapiens has existed, skin color diversity represents a tiny sliver of that timeline. A few thousand generations out of hundreds of thousands of years. Underneath all of it, humans remain remarkably similar, genetically, no matter what continent their ancestors ended up on. That person standing in the East African grass 200,000 years ago had no idea Europe existed. No idea Asia existed. No idea that their descendants would eventually build cities, cross oceans, and argue about identity in ways they never could have imagined. But inside that one person was the genetic starting point for every human being who would ever live. So the next time you look in the mirror, you're not looking at something separate. You're looking at one small variation in an experiment that's been running for 200,000 years. And the story, for every single shade looking back at you, starts in exactly the same place. If this is the kind of question you like having answered, this channel exists for exactly that. Subscribe to the Knowledge Vault, because the next mystery is already waiting.